Welcome back. In the last video we talked about strings and how we might want to use those to manipulate file names, for example. At the example that we came up with at the end, the file extension ended up being .png.tiff. Now we would like to trim off those .png characters, or the .tiff characters actually. How do we do that? We do that through a process called indexing. Indexing is a fundamental concept in programming that is related to finding where things are in multi-element objects like arrays or strings. So strings are composed of multiple character elements stuck together, strung together. They are a character string, whereas arrays are multi-element containers that contain either exclusively numbers or strings. In the macro language, in other programming languages, arrays can contain a whole bunch of different things, particularly in Python, where you can have arrays of arrays called list. Anyway, digressing there. So we want to use indexing to be able to find specific elements within an array or within a string. How do we do this? Pretty straightforward. First, I'm going to start off by generating an array. So I'm going to use the get directory command to find us a folder that contains a list, a long list of files, and then I'm going to generate a second variable called flist, and that's going to use the get file list function. And the get file list function requires you to point it at a directory, and that directory is going to be specified by what we chose in fpath. So I'll copy that, paste it in here, and then I'm going to run the code. I'm going to use the array.print command, and that's going to get us the when you want to get the output of an array, you have to use array.print. You can't just use print, but that's going to print the output of flist. So I'll find where I'm going. So this is a file. You can see here this is a folder that contains multiple files. Undefined variable there. It's because I need to capitalize array. This is a very useful learning opportunity here for everyone, including myself. Okay, this folder will do. You can see here that I now have a long list in the log. I now have a long list of what look to be a bunch of file names, which is what they are, and these are separated by commas. So each of these comma-separated values is a different value in the array. If I wanted to get a specific file from that file list, I would put a number in square brackets. So instead of printing the whole list, I'm going to comment this out, and I'm going to replace it with the print command. I'm going to put in flist, and I'm going to put in 0. 0 is the first element of the array. In many programming languages, the first element of the array is indexed at 0. In some programming languages like MATLAB, it's at 1, but in many, like Python, I think C+, and at the very least the ImageJ macro languages, which is what we're talking about, we start at 0. So when I run this and select a, here we go, this is the folder I want. So I've got a huge list of practice images here, and that's going to just print out the first element of that list. If I uncomment this, so this will so here we go. There's the full list, and there is the first element, or the 0th element that has been printed. This is really useful because this allows us to open up specific files from a list. So if I do a string concatenation of print fpath plus flist, so this is the string concatenation that we covered in the last video. Fpath is a string, so when I add another string to it, the item in flist 0 is a string. And so when I concatenate those two values together, I'm going to come out with the full file path of the first item in this file list. So that is where that first file is located. And we could use that with the open command to open that file. And you can see how this might be useful if we were able to programmatically open sequential images. Okay. So that's basically indexing within an array. It's really straightforward. You just need to identify which of the components of the array that you want to index, and then it will find that element of the array. You put it in square brackets, and that's it. We might also want to index strings. So strings are also strings are kind of like character arrays. They're not technically arrays, but they're kind of like, they behave in similar ways. So we may want to index a character array. If I, you know what, we'll stick with this. Okay, we're gonna set a new variable called TIFF_name equals get info image.filename. We're going to be looking at celldiv.tiff again. And so if I print TIFF_name, I would get celldiv.tiff. Now, if we want to save it as a PNG and erase that .tiff, what we need to do is, ideally, we would be able to just take out the first, 8 characters of celldiv. The problem is we don't know for sure. We know that specifically celldiv is 8 plus 4 characters long, those 4 characters at the end of .tiff. We know that celldiv.tiff is 12 characters long, but we don't know if another file we open is going to also have 12 characters long. So we need to be able to remove characters relative to the end of the file, because we know that .tiff, .png, .czi, these are all file, .nd2, these are all file extensions that have 4 characters at the end. So rather than using true indexing, with strings we have to use the substring command. I'm going to make a new variable called IamName, and I'm going to set this equal to the value of the substring command. And you can see when I autocomplete, it's looking for 2 parameters. In this case, it's actually 3 parameters. String, the index of the first character that we want to keep, and the index of the last character that we want to keep. So first thing we need to do is put in a string, and that's going to be TIFF_name. TIFF_name being the result of getInfo file name. We want to keep the first character indexed at 0. And we want to keep all of the characters up until the last 4. So now we can't just say -4, which would be ideal. This is Python. This is how things work in Python. But in ImageJ, you have to use TIFF_name. TIFF_name has a characteristic called .length, which is the length of the character string, and then -4. And if I print IamName and go to my, so now there is our celldiv, right? Celldiv, we've taken off the .tiff. If I adjusted the length of, if I adjusted this value here, I could adjust for different file extension names. For example, if you were working with a file extension that only required 3 characters, you could change this value to 3, and then you would be left with the appropriate number. So if I wanted to save this as a PNG, I could then save as fpath. Fpath isn't a variable right now. Okay, there we go. Fpath's now going to be a variable plus IamName plus, and then we put in the string .png. We have to give this a file type. I'm going to say this PNG, and I'm going to make sure that I'm just choosing the .tiff.png. So I'm actually going to work this one around and clear off the .tiff as well. So tiff name. If we have this file selected, if this is the active image when we run this code, it's going to get info file name for this file. This file has the full name .tiff.png, so I need to change my IM name indexing to length -8 instead of length -4. So now I'll hit run. I'll save this in macro video recordings. I'll save in macro teaching. And if I now go to the macro teaching folder that I have, saldiv.png has appeared. Same as it was before. Okay, that was probably a too lengthy explanation about indexing, which is a pretty simple task, but we use it all the time. So in the next video, I'm going to talk about how we can use indexing in conjunction with a construction called a for loop to open up a sequence of files in an image folder and perform the same operation on all of them. See you then.